Alright guys, let's go. Okay, welcome to halogenoalkane. Everyone have the note? Let's go. Okay guys, looking at halogenoalkane first. Okay, what is a halogenoalkane? Yeah, we always have a C, okay, that is bonded to a halogen. So it could be a Cl, could be a Br, could be a F, could be I. So you see, okay, for chlorine, fluorine, any group 7, right, halogen is highly electronegative. Okay, and carbon is going to be a electropositive now. So which means for a halogenoalkane, this carbon, right, is always a delta plus. Okay, and this delta plus is going to attract what? They're going to attract nucleophile. So nucleophile will go and attack the carbon. Get me? Okay, so always remember CCl is a polar bond. So always remember this bond is polar. Which means, guys, what is my IMF here? My IMF is going to be PDD and ID. Clear? That's it. Alright, I just updated this note to 2026 variant. Oh my god, damn nice. I love this note. Alright guys, next. Let's look at halogen. Always remember halogen are more electronegative than carbon. So carbon halogen is polar and carbon always have a delta plus charge. Okay, and guys, this means that halogenoalkanes are more reactive than alkane. By the way, guys, do you know how to identify a primary, secondary, tertiary? Yes? Let's go. Alright, kid. All the halogenoalkane, I want you guys to start labeling your primary, secondary, and tertiary here. I want you guys to label all. I go washroom. When I'm back, I'll discuss. Yeah, go. Primary, secondary, tertiary. Let's go label it. Thank you. I'll wait. Alright, guys. For primary, always remember primary is when CCl is connected to just one carbon. Secondary is 2 carbon, tertiary is 3 carbon. So let's look at it. CCl connect to just one carbon. That is a primary. Okay, let's look at this carbon. CCl is bonded to 1 carbon, 2 carbon, 3 carbon. This is a tertiary. Okay, guys, what about this CCl? 1 carbon, 2 carbon. That is a secondary. Yes, sir. Alright then, guys, let's look at this. 1 carbon, primary, 2 carbon secondary, 3 carbon tertiary, 2 carbon secondary, 1 carbon primary. Know how to label? One more time. Do you see this is 2 carbon secondary? 1, 2, 3 tertiary. 1, 2 secondary. 1 primary. Can I? Next. Let's look at this Cl. 1 carbon primary, secondary, tertiary, secondary, primary. Yes, sir. So one more time. CCl, 1 carbon. Can see that? Okay, this CCl, 1 carbon, 2 carbon, secondary. CCl, 1 carbon, 2 carbon, secondary. CCl, 1 carbon, 2 carbon, 3 carbon, tertiary. CCl, 1 carbon, primary. Done. Okay. Any question? If no question, let's go. Alright, now the slowest reaction take place with fluoroalkane. Okay, because CF bond is the longest. So guys, as you go down the group, okay, do you see that the bond length get longer and longer? Why? Because CF it's so short, right? CF, then after that we have a CCl, getting longer, we have a CBr, getting longer, we have CI. On one reason, going down, atomic radius increases. Correct. So always remember, okay, this is having the largest atomic radius. Okay, which means you have the lowest bond energy and the most reactive here. Clear. Okay. All right, guys, next, let's look at the halogenoalkane. So halogenoalkane, we can get it from alkane under UV light. So if we take alkane under UV light, okay, so reaction is free radical substitution. All right, guys, if it's alkene, it could be electrophilic addition. Okay, at room temperature will do, yeah. All right, guys, next. What about alkene? If you look at alkene, also undergo electrophilic addition, okay, of hydrogen halide and turns into a C double bond C. That's it. Clear? All right, guys, now substitution from alcohol. So, guys, you can also substitute from an alcohol. So, if you want to get a halogenoalkane from alcohol, right, there's a few things that you can substitute it with. Okay, so the first one, right, we can always substitute it with a metal halide. Okay, which means like a NaCl, then with a concentrated H2SO4. Okay, then we can use a PCl5 or SOCl2. This I will talk about it later on, yeah. All right, guys, next. So preparation of halogenoalkane. So I already have a summary for you guys, yeah. So this entire thing you can just read it. Okay, that summarizes all the preparation. But eventually we're gonna cover each and every one in detail. So I just put it here as a summary for you guys. You can just read it. Okay. So now let's move on to page 3. All right, guys, the first reaction that we have, right, it's nucleophilic substitution. Always remember, yeah, okay, I just mentioned to you that, okay, so your halogenoalkane, CCl is polar, so carbon is delta positive, always attract nucleophile. So the first one is when aqueous NaOH, if I have an aqueous NaOH, or KOH is heated with a halogenoalkane, okay, and alcohol is formed. So guys, just have to substitute your Cl with an alcohol. Yeah? Please draw it out now. All right, guys, now this Cl is going to get substituted. 1, 2, 3, 4. You have OH. And a Cl minus. That's it. All right, guys, this OH minus behave as a nucleophile. So it donates a pair of electrons to carbon atom that is bonded to halogen. That's it. All right, guys, reactant-wise, we have halogenoalkane plus NaOH. We just need to heat it. So reaction, halogenoalkane is going to turn into an alcohol. Mechanism is nucleophilic substitution. Done. All right, guys, next. It's with a cyanide ion now, Cn minus. So this Cn minus, yeah, is a very popular reagent. So Cn minus, right, will always forms a product with extra one carbon. So if you want the product to have one more carbon, and okay, the only reagent that we can use is a Cn minus. Okay, so for Cn minus, a solution of KCN in ethanol, we can take a KCN in ethanol that is heated with a halogenal alkane, and you will get a nitrile is formed. That's it. Okay, guys, I will give you one example. Alright, guys, again, please draw it out, yeah. Your Cl, right, is gonna get substituted. One more time. Your Cl is gonna get substituted by a Cn minus, yeah. So eventually, what's gonna turn into? Your Cl is gone now, guys. You see, your Cl is bye-bye, no more Cl. So what we're gonna get is a C triple bond N. How do you draw a C triple bond? C triple bond N. 1, 2, 3. And alright, guys, you see, from how many carbon? 1, 2, 3 carbon turns into 1, 2, 3, 4 carbon. Get me? So this reaction will always increase the carbon number by 1. So from a 1, 2, 3, this we call it as a chloropropane. 1, 2, 3, 1, 2, 1, 2, 3, 4. Okay, this is a 1, 2, 3, 4. 1, 2, 3, 4. This is a 2-chlorobutane. Okay, so 1, 2, 3, 4, can see it's a 2-chlorobutane turns into a 1, 2, 3, 4. It's still a 4, but this turns into a butane nitrile. And you have a methyl group in second position, 2-methyl butane nitrile. So you see, right, guys, from a 4 carbon turns into a 5 carbon now. Clear? So a nitrile always increases the carbon number by 1, yeah? Please remember that. Okay, so note that an extra carbon has been added. Okay, to the original halogenal alkane chain. So I can split this into half. Okay, and guys, this entire thingy, right, I can write it as okay, so for example, if I have a nitrile, so nitrile, right, can be reduced to amine or can be converted into a carboxylic acid. The reaction does look something like that. So let's say if I have a CH3, okay, and a C triple bond N, and I'm reducing it with a hydrogen. So if you reduce it with a hydrogen, right, LiAl, I use LiAlH4 and reduction reaction happens. Okay, so this will turn your entire nitrile into an amine. So how can you turn it into amine, right? You just have to break the triple bond here. So it's no longer a triple bond and try to add hydrogen next to it. 1, 2, 3, 4. 4 hydrogen. So this will turn into a propyl amine. That's it. Okay, please write down. Okay, guys, let's say if you don't want to reduce it to turn into amine, I can also turn it into a carboxylic acid. So the same thing, yeah. This one. Okay, this time, right, if you want to turn it into a carboxylic acid, very simple. I just have to add H2O and a H plus. And the reaction, we call it as hydrolysis by acid. Okay, because we are adding H plus, right? So acid hydrolysis. Alright, so this could be the second reaction. So guys, for acid hydrolysis reaction, right, the the triple bond end, right, is gonna get broken completely. Okay, so this C triple bond end is gonna get broken completely, like entirely broken. Okay, so it's gonna turn into something else. This one break completely. The front part is gonna turn into a carboxylic acid. C double bond O and an OH, carboxylic acid. And the nitrogen is gonna combine with all the N and turn into ammonium. That's it. Done. Okay. And guys, by the way, this we call it as a propanoic acid. This is acid hydrolysis, guys. A nitrile reaction, what it can turn into, this two equation is very popular in the exam, especially in your P2. Paper 2 popular. Okay, so please write it down. Alright, guys. Reactant-wise, I have a halogenoalkane plus a KCN in ethanol. Okay, so remember your KCN in ethanol and you have to heat it, yeah? So halogenoalkane plus a Cn minus is going to turn into a nitrile. So once a nitrile is formed, a nitrile can undergo two more reactions to either turn into an amine or a carboxylic acid. To turn into an amine, this we call it as reduction. To turn into a carboxylic acid, acid hydrolysis. Okay, mechanism, nucleophilic substitution. That's it. Okay, good. And guys, how can you increase the carbon number by 1? Like for example, from propane turn into a butane. So always remember in our entire syllabus, we can only increase the carbon number by 1 by a reaction with a Cn minus. That's it. So to increase the carbon number, the only possible way is by a nitrile. That's it. Let's look at page 4. Yep. All right, guys, let's go. Okay, guys, next we have a substitution reaction with ammonia. Michelle is here. Alright, guys, when a halogenoalkane is heated, okay, with NH3 in ethanol, and you have to heat it under pressure. Okay, you will get an amine is formed. Alright, guys, next thing is you need to know the reaction. So the reaction wise, okay, we have this. Okay, so your NH3 kit must be in ethanol. Okay, so the NH3 will substitute into the Cl. Okay, so eventually you will get this thingy. Okay, you will get an amine. This we call it as an amine, yeah. Okay, and HCl is formed. Alright, guys, what is the type of amine? We call it as 1, 2, 3, 4. I'll get you the name up. Okay, this we call it as 2-butylamine. Okay, 1, 2, 3, 4. You can see 1, 2. Okay, so we call it as 3-methyl-butylamine. Okay, please write it down. Alright, guys, reactant-wise, what do we have? Guys, for the reactant, first we need a halogenoalkane. Second, I need NH3 in ethanol. Remember, I need our NH3 in ethanol, and guys, has to be heated under pressure. So haloalkane is gonna turn into an amine. Reaction-wise, we call it as a nucleophilic substitution. Yeah, please write down. What does the ethanol to do again? Okay, I will talk about the ethanol later. The ethanol is okay. Why is this amine this name? Because your ethanol is acting as a solvent. So why is this so? This is a 4-alkane. You can see 1, 2, 3, 4. So which means it's a butyl or butylamine. Okay, that's it. Then you see your CH3 group, right? Your CH3 is in the third position, correct? So we call it as 3-methyl. Okay, Alright, guys, one's done. Next. Alright, guys, next what we have is the mechanism for any halogenoalkane. So any halogenoalkane, right? Remember that you have a halogen here, which is more delta negative, more electronegative, which means your carbon is gonna be delta positive. Okay, and in this reaction, this delta positive is gonna get attacked by a nucleophile. Can see. So a nucleophile is always gonna attack your carbon. Okay, and in this reaction, we always have a nucleophile that attacks the carbon because halogen is more electronegative than the carbon. Then carbon attracts electrophile. Eventually, halogen is gonna be replaced by a nucleophile. That's it. Please write down. I go refill water. Go, go, go. Alright guys, let's go. Okay, 1 minute. So let's look at your nucleophilic substitution. Basically, there's two mechanisms for nucleophilic substitution. We call it as SN1 or SN2. Yeah. S stands for substitution. N stands for nucleophile. First order or a second order. Guys, the order of reaction you don't need to know, yeah, because order of reaction is only in A2. You just have to know, for at your level now, you just need to know how to identify which one is which. That's it. You don't need to know the Y. The Y, leave it to A2. Okay? Guys, let's go. XN2 mechanism. Let me tell you about a story about. Yeah, oh, Valentine is near, right? Yes. Brad, I'm gonna use you. I think this is you. Yes, I'm pretty sure this is Brad. I'm just gonna put here Brad SN2. Hi. So guys, SN2, right? What 2 means? Remember this. 2 in your term, right? In your Gen whatsoever, you guys are Gen what? Gen Alpha. No, you guys are Gen Z. Gen Z term, situationship. Shit. That's you, Brad. So the 2 stand for, right, having 2 relationship at the same time. That's 2. Okay, so 2 means having 2 relationship at the same time. So it's for a primary halogenoalkane. Alright guys, now let's look at the primary halogenoalkane. I'll show you why is it SN2. I'll explain later. When the sun goes down, bands would play. I'll always remember us this way. Alright guys, we have a primary halogenoalkane. Okay, and guys, you have a delta plus and a delta minus here. And guys, right now I have a nucleophile comes in. So you see, okay, I have a guy in the middle. So this guy, right, is already having a girlfriend, Brad, already dating this girl. But at the same time, he get to meet this girl and then a bit interested over this girl, Alex, maybe Alex, put Alex. Alright, so what's gonna happen is that this fella is gonna go on a situationship. It's gonna be like, oh, forming a relationship with a girl, at the same time breaking up. So you break up and form a relationship at the same time. So you are handling 2 relationships at the same time. That is what it means by SN2. Okay, so eventually you will get a transition that looks something like that. Okay, you have OH. You also have a Cl. So guys, what this thingy means this dotted line is showing you that, right, your bond is broken, one of the bond is broken, another bond is being formed at the same time. And guys, you see, if you are doing this, right, it's not acceptable. Technically saying you don't do this, you don't form a relationship, break up at the same time. So this is not acceptable. That's why it's negative. No, don't do. No. Okay, so that's why you see a negative charge here. Okay, finally, at the end of the day, I'll have this. and your Cl is being replaced by an OH. Okay, then you have a Cl minus is formed. Okay, please write it down. Once done, we are moving on. Clear? Alright guys, now let's continue for SN2. So SN2 only occur for a primary haloalkane. Okay, remember this, a primary halogenoalkane will always be SN2. So the OH donate a pair of electrons to the partial positive carbon atom, forming a new covalent bond. At the same time, the Ci bond is broken. Not Ci, this is a CCl bond is broken. That's it. So you see, you are forming a bond at the same time stepping into a new relationship. Oh no. Okay, so this type of bond breaking is a heterolytic fission because you are getting a positive and negative charge. Alright guys, for SN2, the graph does look something like that. That's your product, that is your reactant. Your highest transition here, it's a negative charge, remember. Heterolytic fission means uneven breaking of a covalent bond. You can refer to chapter 13. Alright guys, now my question is why SN2? Okay guys, why SN2? Always remember the 2 is a bit confusing one. So 2 stands for two things happening at the same time. Remember this. So you have bond is broken and bond is formed at the same time. Okay, so this is what it means by 2. Alright guys, now the contradicting part is for SN2 is always for primary haloalkane. And this, when you are drawing the graph, it's just one peak. And it's a one-step reaction. Oh my god. You see, it's a bit contradicting. Alright, so don't be surprised if the number doesn't make sense to you. Yes, it doesn't make sense. At your level, it doesn't make sense. Like suddenly SN2 for primary halogen, one peak, one step. But the 2 means 2 things happening at the same time. That's what the 2 means, okay? SN2, single step reaction, transition has a negative charge. Once done, next page, page 7. Any question? Alright guys, now let's look at SN1 mechanism. Okay, for SN1 mechanism, it's for a tertiary halogenoalkane. Okay, let's go. So, for tertiary halogenoalkane, this is the story. Okay, this is by right a relationship, new relationship should be formed this way. So I'll show you one example. I have a CH3, I have a C2H5, I have another CH3, that's a tertiary. This is too huge. And I have a Br. Okay. So guys, now you see, this is Joe Boy. Someone take my Joe Boy. So you see, I have a Joe Boy in the middle. But you see, this fella is surrounded by a CH3, C2H5, CH3, and a girlfriend. So these four fella, right, are fat, like big molecule. Okay, so it's gonna block off everywhere. Then you see right now I have a new lady. This lady, right, has nowhere to approach the center carbon, like because everything is being blocked off. Reason, all these are big molecule. So unfortunately, this fella has no chance to even approach the center. So what happened is that to form a relationship, this Joe boy has to make himself available first. So we have a delta plus, delta minus. So they're gonna break the bond first. So you have to break the bond first, yeah. So you see, right, usually a breakup, right, is always kind of slower. So we have a slow breakup here, slow step. Like breakup, I want to break up, then get back together, break up, get back together again. Oh my god, like my friend. Then eventually, boom, broke up already. So after breaking up, so this central atom, okay, this guy is available now. We have a positive charge available. Then my OH be like, oh my god, you are single and available, single, ready to mingle. Here we come. Whee! Okay, so your OH is gonna attack the C, and eventually it's gonna turn into this thing. OH is here, and I have a Br minus. That's it. Okay. Alright, guys, this mechanism occur when a tertiary, remember a tertiary halogenoalkane, okay, reacts with a OH minus. So the first step always involves a breakup first. You have to break it first. So to turn into a carbocation intermediate. Okay, so to make the carbon atom available first, yeah, a breakup has to happen first. Okay, and after that, the carbocation attack the nucleophile. Alright guys, as for the graph, it does look something like that. We have a two-step reaction. 1, 2. Arizona sky. Product, reactant. Alright guys, in between this is where our intermediate is formed. The carbocation, understand? A carbocation intermediate is formed. Okay, the first EA, I call it as EA1. The second is a EA2. EA2 is always smaller than EA1. Okay, so activation energy for the first step is higher. Alright guys, again EA1 is always greater than EA2. Okay, so now let's look at the explanation, like why. Why SN1? What it stand for? Okay, the one, yeah, kid, stand for one step at a time. You go slow. Get me? So basically, you have to break up first, make yourself available first, okay? Then form a bond later. Understand? Okay, so you see, you break up first, you form a bond later, is positive. You can do it this way. Get me? But you see, if you are forming and breaking at the same time, bro, don't, this is negative. Okay, Hannah. So remember the story, So guys, this is a two-step reaction. You see, a bit contradicting. We have two pigs again. Oh shit. And it's for tertiary haloalkane. And guys, remember that it forms a positive carbocation. Okay, guys, this mechanism is a two-step reaction. Remember, it's a two-step reaction. So unlike SN2, it involves a slow step and a fast step. So guys, the slow step, right, always involving a formation of carbocation. So this is a breaking of your CX bond, yeah. Okay, slow step is also known as rate determining step. So none of the thing here you need to know. It's more applicable for A2. So second step, it's a fast step which having a lower activation energy. Guys, let's say if you have a secondary, secondary, right, can undergo both SN1 or SN2. It doesn't matter. Okay, so secondary can be either SN1 or SN2. Doesn't really matter. Okay? Alright guys, now let's look at page 8. Page 8 will tell you the explanation behind, like why SN1 or why SN2. Alright guys, basically there are three carbocation for you to consider, which is a primary, a secondary, and tertiary. You guys know how to draw, right? Primary, secondary, tertiary. Tertiary is the most stable. Primary is the least stable. Okay, please write it down. Alright guys, so know that carbon atom with the positive charge only has 3 covalent bonds. Okay, the more alkyl group adjacent to the positively charged, the more stable it is, yeah. Alright guys, remember this, alkyl group have a property, we call it as electron donating property, correct? And guys, this electron donating property always have a positive inductive effect on other adjacent group. Positive inductive effect. First point, second point. So tertiary carbocation is the most likely to form. On one reason, they are the most stable. Remember us this way. Done. Alright guys, now you see why a carbocation is formed in SN1 and not SN2. Okay, or another way is, hey, why? Another question is, why a tertiary only undergo SN1? Like, what's the reason? Okay, so you have to tell me, oh, tertiary, because there will be a formation of carbocation and it's very stable. Okay, so I can say that tertiary carbocation are more stable than either a secondary or primary. Okay, so that will score you 1 mark already. Due to the positive inductive effect, that is the second mark. So first mark, second mark. Alright guys, alkyl group tends to push electron. Okay, because they have this electron donating property, right? Third mark. Hence reducing its charge density. That's it. Okay, Alright guys, the next one what we have is effect of halogen on rate of nucleophilic substitution. Guys, for nucleophilic substitution, right, let's look at the bond length here. So we have CF, CCl, CBr, Ci. Which one is the biggest? So if you look at Ci, right, okay, this fella is having the lowest bond energy, correct or not? Why though? One reason, I has the biggest atomic radius, correct or not? Why? So when your atomic radius is big, which means that your Ci bond, right, is the longest, correct or not? Longest means biggest also, yeah. San. Okay, then eventually, it's the easiest to break. It's the most reactive one. Okay, please write it down. Alright, guys, please write it down. Sure, I haven't finished copying yet, the previous one. Okay. I'll scroll back to the previous page. Go, copy, go, copy. Done. Okay. Alright, guys, let's go. The effect of halogen on the rate of nucleophilic substitution. The rate of nucleophilic substitution of halogen by hydroxide is always the fastest with any iodide. Okay, and slowest for F. So decreasing rate is Ci is the fastest, then Cbr, then CCl, and slowest is EF. Why? Because Ci is longest and weakest, and is the easiest to break. Done. Okay. Once done, next page. We are almost done with chapter 15 already. Have 2 more reactions and we are done. Oh, good. No, I cannot sit. Sit now. It's becoming so fat now. How? You never come join me. Where go all the Korean kid very rich one. Alright, guys, now we have elimination. Okay, let's look at elimination reaction. So, what is elimination, right? You are removing a small molecule, okay? So, this involves the removal of a small molecule. Okay, in the case of a halogenoalkane, what are we removing is H, X, such as a HBr, a HCl. These are what we are removing. Okay, boy, I'm gonna give you a structural formula for you to visualize better. Alright, guys, you see, for this one, my NaOH has to be in ethanol. Okay, it has to be under ethanol, It's right now. And kid, the next thing is, what are you removing? You are removing a Br. Whee! Okay, and look at the carbon next to it. Then you remove a H. So another H is removed. Whee! Then eventually it's gonna turn into an alkene. Okay, you have an alkene, and you have an NaBr and a H2O. Okay, please write it down. Alright, guys. That's how you picture it, Okay, once done, we can continue. So the reaction product will have a C double bond C. And an alkene is formed. Okay, guys, the reagent that we are using, remember, it must be NaOH in ethanol. Okay, so remember NaOH in ethanol. And you have to heat it. That's it. Heat under reflux for alcohol, not this one. I will talk about heat under reflux later on. So many things. But boys, organic is all about memorizing. Okay, but boys, now I want you guys to draw out the product. We're gonna eliminate this thing. Alright, guys. I have a chloroethane here. Okay, I want you guys to eliminate this under NaOH in ethanol. Please tell me what are the products that you'll be getting. Go. Please start drawing it out. Okay, eliminate everything and tell me how many different products you will be getting. Okay, so please tell me how many products you'll be getting. Draw it out. I want you guys to tell me. I'm not gonna give you an answer. I'm gonna throw my trash first. I'll come back in 1 minute. Hi guys, company. For help. 3 Sure. Sure or not? I only have answer from Joe Boy. Other kid. How? No try not. Try Thank you so long. Thank you, boy. I'm proud. 2. Bernice, you're missing out 1. Alright guys, I'm proud. You guys are trying it. Okay, let's go. Alright guys. So I know that I'm removing my Cl here. Okay, so you see, right, this CCl is bonded to a CH3, bonded to a CH3, bonded to a CH, like that. So the first one, I'm gonna remove a hydrogen from here. So I'm gonna do it here. I'm gonna put a blue color to indicate. So I remove Cl, no more. Bye-bye. And this CH3, I remove 1 hydrogen. So this is where my double bond is gonna be. First one. When the sun... Correct. Alright guys, the second one, I'm gonna remove a hydrogen from the lake, from this lake. There's a hydrogen here, right? There's a CH3. I can remove 1 more hydrogen here. I'm gonna put a green color to indicate this is me removing from here. So I can remove a Cl and double bond is gonna be here now. Correct or not? Last one, I can also remove a hydrogen from this side, this one. That's it. Remove. So the last one, I'm gonna indicate it with a red color. This is where I'm removing. Correct. A double bond. Done. Understand? Know how to remove? Okay, all good. Nice. All right, guys, I have another question. Please tell me how many total isomer there is in total. I want total isomers. Let's go. What about the total isomer, kiddos? All right, guys, total isomer, please include your cis trans. I want you guys to work it out how many cis trans we have it in total. Total including cis trans. Produce all three at the same time, Brad. You get three different products at the same time. Okay? The sun goes down.
Position of double bond can change.
No, your position of double bond cannot change. Okay, what happens that you have to tell me which double bond is exhibiting a cis trans. Okay, so what we are looking for is a cis trans, my friend. Sorry? Only the third one. The answer is none. None of them have a cis trans. First, this carbon is bonded to hydrogen. You are doing your dragon ball. You can see, right? Hydrogen, hydrogen, dragon ball, nope. Second one, also hydrogen, hydrogen, dragon ball, cannot. This one, why cannot? CH3, CH3, also a dragon ball. So no cis trans, 3 isomer in total. Get me? Hey, this type of question will come out in the exam, you know. They want you to get how many isomer. They are not telling you, or they won't even draw it out for you guys. They will just say how many isomer in total. Okay? Clear? There is no optical isomer. Hey, there is optical isomer. I just realized. Thank you. Oh my god. Thanks, boy. There is optical isomer. This is a chiral center. This is also a chiral center. So yes, there is optical isomer. Okay, so you have a chiral center here. You have a chiral center here. Yeah, boy. So it's gonna be 2, 1, 2, 2, 1, 2, and 1 isomer in total is gonna be 5 isomers in total. Thanks, Yongshin. Yeah, why? Why the traffic today so bad? Like jam everywhere. The isomer thingy, this is okay. So guys, some of you guys still don't get isomer. Do you understand why this is a chiral center or not? Yes, you know, right? Okay, Gaga that asked me the chiral isomer thingy. 4 different group, what? Can see 4 different one. So which means this will have a mirror. So basically there's 2 thingy here. This also there's a mirror. So you have a B, then you also have a B primer. This is just a C. So you see 1, 2, 3, 4, 5. That's it. Last don't have what? Last got no chiral center. Double bond cannot be a chiral. This is a HH. This is a H3. This is also a H3. That's it. Okay, okay, guys, now the importance of reagent. So guys, you see the reagent is very important, like if I put NaOH, like NaOH alone, right? Okay, so remember to tell me what is the condition. You see, if I have a chloroalkane and I just write it as with OH minus. Okay, so you see the reaction with NaOH, if I just write NaOH with aqueous, okay, this is gonna turn into an alcohol. You get me? Okay, and this is a nucleophilic substitution. But if I were to write this in NaOH in ethanol, it's different story now. So this is gonna be, I can remove my Cl and H. I will have a double bond here, or I will have a double bond on the second and third. And guys, this reaction is elimination. Let's see that we'll either have an elimination reaction or a substitution reaction, depending very much on the condition. Okay, please write it down. Okay, guys, let's go. Okay, reactant-wise. Okay, we can have a halogenoalkane. Condition and reagent, if I have a NaOH aqueous, I will get an alcohol. This is SN1 or SN2, yeah. Okay, but if I take NaOH in ethanol, it's different story now. I'll get alkene and elimination reaction. That's it. Guys, we are back. Let's go. Done, any question? No, let's go. Faster get IG. Valentine soon already. Guys, Valentine this Saturday, enjoy your date. Hey, bread, SN1, hey. Okay, let's continue. Okay, guys, halogen can be converted into alcohol, okay, by heating under reflux. Hi, guys. So,
Fork and spoon.
fork and spoon, You ask Jenny. Jenny got that. Okay, so turn into a halogen, turn into an alcohol, yeah. The breakdown of halogen into alcohol, we also call this reaction as a hydrolysis reaction, okay? So this silver nitrate is acting as a nucleophile, yeah. Got fire, good. She's bringing it to you. So sweet, you see. What means Saturday you have plans today?
B.
Yeah, got Valentine already.
B.
You only have 88 ringgit lah. In your 88 ringgit is good enough ah. Can go KFC, McDonald's, bro.
Can what? Kayu.
Yeah, can go Kayu Ara some more. Ah, you waste so much money for what? Okay, so why not Johnny bring to you one? She shy ah. You see, Joe boy, you see, you making people shy. Shy what? Yeah, shy what? Johnny, shy what? Okay, so plus AgNO3. Guys, your silver nitrate has to be in ethanol, remember? Okay, your silver nitrate in aqueous silver nitrate in ethanol, okay? So guys, basically when you see the word aqueous, right, which means there is water in it, get me? So this thingy is gonna turn into an alcohol. You're the one designed for me. Okay, we have an alcohol, and guys, eventually we will have a Cl minus and combine with a Ag plus, and this will turn into a BPT, which is a AgCl BPT. Get me? Then you also have a H plus and a NO3 minus. That's it. Alright, guys, that's it, yeah. Color of precipitate with chlorine is white, with bromine is cream, with iodine is yellow. AgCl, AgBr, AgI. Reaction here is the slowest with chlorine, fastest with iodine. Alright, guys, your reactant is gonna be aqueous AgNO3 in ethanol. Remember, I need to see the word aqueous, I need to see the word in ethanol. So if I take a halogenoalkane plus a silver nitrate, I'm getting an alcohol and a PPT. So this is SN1 or SN2 reaction. That's it. And guys, we are done with chapter 15. Yeah.